Now we go to the next part, grow and propagation of starter coaters. We grow them to have enough number for fermentation. And these are the form of starter coater that we can obtain from the market. So can be liquid form, can be spray dry, can be free dry, or concentrated and frozen form. And each form contains certain concentration of bacteria. Okay. Liquid form is traditional form, but some companies still apply this. They have for themselves, they owe themselves starter coater and they keep for themselves. They don't share. Okay, keep the secret. But the other one, other form, then we can buy. Actually, the company can buy from a supplier and then use it. There's one important fact we need to know is that the starters can get easily contaminated with bacteriophages. Bacteriophages are viruses, but these viruses contaminate into bacteria that can weaken bacteria or that can even kill the starter coater, the bacteria, and make the starter coater become very weak or already dead. Okay, and then when you do fermentation, you have issue. We call it slow fat and dead fat. Slow fat means the whole batch of fermentation becomes slow, or will not fermentation at all. So you call it dead fat, and that is very large economical loss. So here, if we use a liquid form of starter coater, then we need to activate them in a liquid medium. You use MRS medium, for example, a good nutrient solution for them to grow. And then you also use that medium to grow them, to activate them, to grow them into higher number, larger volume. You call it mother coater. And now you inoculate into milk already. You use milk to grow them. We call it intermediate coater. And then we have bun starter, like you do fermentation in 1 tongue before you have enough to do fermentation for 20 tongues or 10 tongues, for example. Just many steps to have enough. But for example, if you start from concentrated frozen starter coater, this one has 10 power 10, 10 power 11 CFU per milliliter. This one only 10 power 8. This one is 10 power 11 CFU, mean 1,000 times more than this form. And then you don't need to multiply or grow in many steps. You can directly inoculate into a large tank for fermentation, or you can grow them but only one step and then it's enough. Or this form as well contain higher concentration of lactic acid bacteria, so you can do inoculate directly. What are the advantages of this system and disadvantages of the above and the below system? For example, this one is actually traditional way, and the company normally own themselves the starter coater and they keep for themselves. Every time they use, they need to multiply like this. Then it takes quite some time. It takes quite some labor. It takes quite some space to do it, right? And that's the first disadvantage. The second disadvantage is that when you do many steps, then maybe you already have the high risk of contamination with bacteriophages, viruses. That's also not good. And the other disadvantage is that when you grow through many steps, maybe you don't maintain very well the ratio between bacteria. For example, in making yogurt, you need Streptococcus thermophilus and you need Lactobacillus bulgaricus in a good ratio, 1:1. But if you grow through several steps, maybe the ratio are not maintained anymore. Or one become more, one become less. Why? Because the condition can be more favorable to this one, but not to the other one. So those are the disadvantages of this system. But one big advantage is that you own yourself a starter coater. So you have the properties of that starter coater that only you have, only your product has. And the below one is actually normally you buy from a third party. When you buy the starter coater, then other company, your competitors also can buy from a third party. So you have the same starter code. but then you do less step, mean you maintain better the ratio, and then you have lower risk of contamination with undesirable microorganisms as well. So now we look at the reason why in several cases the fermentation is not fast enough, the fermentation is slow, or even the fermentation does not occur. What can be the reason? First, there can be the variation in milk composition. As we discussed in chapter 2, in chapter 3, we know that there are a number of factors that the milk composition can be influenced, right? So there can be variation in milk composition, so it will influence the fermentation. So the fermentation can be a bit slower or a bit faster. The second reason, okay, and this happened also, that's why I mentioned here, that the infection with bacteriophage, the infection with viruses, that will weaken the starter coater or that will kill the starter coater, and then you have slow vat or dead vat. Slow vat means the fermentation becomes slow. When the fermentation becomes slow, it's become risky because it's a chance for undesirable microorganism to grow. When the one we want to grow and they don't grow dominantly, then that is a chance for something else to grow. And the third reason, this also happen especially in developing country, the antibiotic residues in milk. Antibiotic, maybe they use to treat the cows when the cows are sick, or antibiotic is somehow like already unintentionally or intentionally added in the feed for the cow. And when the cow eat these feeds, the antibiotic will go to the milk. And when milk has antibiotic is actually is prevent not only the bad microorganism but also the good one, prevent all microorganism. So when antibiotic residue occur in the milk, the fermentation also become influenced, of course, either slow fat or even dead fat. The other reason is can be the residue of detergent and sanitizer. Sometimes you have a container, you wash the container and you use the detergent to wash, you use sanitizer to disinfect it, but then you don't rinse it very well, for example, and then you contain milk inside, and milk will have a certain amount of these substances and that will influence the fermentation. Or sometimes the naturally occurring antibacterial compounds in the milk, for example, the lactin, for example, lactoperoxidase system, lactoperoxidase together with H2O2. It's called lactoperoxidase system, convert thiocyanate into hypothiocyanate that we just explained. So this system prevent the growth of certain microorganisms. Maybe it's also inhibit a bit the starter coater to grow. But this is natural in the milk. Okay, so these are the reasons sometimes fermentation is not fast as we expect. And then we can look at what is the reason and then to treat to have solution.